Hello, and welcome back to Physics with ZUKI. In today's episode, we're talking about Kirchhoff's loop rule. Kirchhoff's loop rule is also called Kirchhoff's voltage law, KVL for short. It says that the sum of the voltage in a loop adds to zero. Now, what is a loop? Well, when you can draw a line through a circuit from the battery or anywhere, all the way back to the beginning, that's a loop. This is also a loop. And this is also a loop. Now, looking at this circuit, there's only one loop. And what did we learn from Kirchhoff's voltage law? We learned that the sum of the voltages in a loop should equal zero. That means the voltage from the battery plus the voltage across the resistor should equal zero. And this gives us that the voltage from the battery is equal to the negative voltage across the resistor. And that's true. If you measured the voltage across the resistor with a voltmeter, you would find that it would equal negative V. Now in this circuit, we have two resistors, so we have a new problem. We still only have one loop, but how do we add two resistors instead of one? Well, now our equation looks like this. The voltage from the battery plus the voltage over R1 plus the voltage over R2 is equal to zero. That means the voltage from the battery is equal to the negative sum of the voltage across first resistor and the voltage across the second resistor. So if you had the resistance values of R1 and R2, you could solve exactly for V1 and V2. Now what about this circuit? It's a little more complicated because now we have two resistors in parallel. That means we have two loops we can use KVL to analyze. The first goes through the battery and through R3 and back to the battery. The second goes from the battery through R4 and back to the battery. So now we have two separate equations. We have the voltage from the battery plus the voltage across resistor 3 is equal to 0, or that the voltage across resistor 3 is equal to negative V. We also have the voltage from the battery plus the voltage across the fourth resistor is equal to 0, so we have that the voltage across resistor 4 is equal to negative V as well. So we know the voltage across R3 and the voltage across R4 are both negative V. So it's interesting here, the voltage across R3 is equal to negative V, and the voltage across R4 is also equal to negative V. And that's why we measure voltage in parallel. So if we attach a voltmeter across the battery, with the positive end on the top and the negative end on the bottom, we measure a voltage of V, which is unsurprising. Now in order to measure the voltage across R3 and R4, we need to translate our voltmeter around this way so that the positive side is still on the left and the negative side is on the right. And here we would measure a voltage of negative V, which is what we found earlier. You also need to be mindful of which direction you connect the voltmeter in. This way, you're measuring like if you had held the voltmeter in your hands and you were moving around the circuit like this. See, it's in the same orientation. Otherwise, you would measure the same voltage but would be off by a sign. And that's all we have time for in this episode. Thanks for watching. Please hit the like button if you enjoyed this video and consider subscribing for more Physics with ZUKI. Stay tuned for more circuits videos and see you next time. Bye bye!